Another application of differential equation is in electric circuit. We have here an electric circuit wherein we have here our voltage represented by E, and then E, the voltage source, our unit is in terms of volts, and then R, our resistance in terms of ohms, the unit, and then L is the inductance in terms of Henry, our unit. Now, in the application of electric circuit for differential equation, we will make use of this equation, L times the change or the time rate of change of your current, which is represented by I, plus I times R equals E. Okay, and then this di over dt will be multiplied by L. Now, to give example for the application of electric circuit, we have here an inductance of L henries and a resistance of 10 ohms are connected in series with EMF of 100 volts. If the current is initially 0 and is equal to 9 amperes after 1 second, find L and the current after 0.5 seconds. Okay? Now, we will write first the given data based from our example. We have 10 ohms, L henries. So our inductance in terms of L. So we will write here L. Okay, we have here L, which is equivalent to inductance, that is L henries. So we do not know the value, which is unknown. And then the resistance is 10 ohms. So we have our R, which is equivalent to 10 ohms. And then they are connected in series with EMF of 100 volts, our electromotive force, which is equivalent to 100 volts. So that will be our E, okay, which is equivalent to 100 volts. If the current is initially 0 and is equal to 9 amperes after 1 second, find L and the current after 0.5 seconds. Okay, now to solve this problem, we will use this equation. Okay, I am rewriting this equation. We have our L, okay, so we have our L, and then the derivative of our current with respect to time. Okay, and then after that, of course, I times R. Our R is given, which is equivalent to 10 ohms. So we will make use of 10 ohms. So we have here plus 10 as our R, and then I, which is unknown. So 10I, okay, which is equivalent to, okay, I will change this one. We will erase, and then I have here my I, which is equivalent to E, which is also given as 100. So we have here 100. Notice we have here our L. So we have to transfer L to other variable, or let's say terms of the equation, so that our equation now becomes di over dt plus 10 over L times I, which is also equivalent to 100 over L. Okay, so in other words, we multiply both sides by 1 over L. So when we multiply by 1 over L, we will cancel L, this part, and then 10I over L. So the result here is 10I over L, and then 100 over L. We have here 100 over L. So we multiply 1 over L to both sides from this equation. Now, if you have noticed this part, this follows this equation. We have dy over dx plus p of x y, which is equivalent to q of x. This is our first order linear differential equation. Instead of y, we have here your I, and instead of p of x, we have here 10 over L. And then our q of x is 100 over L. So if this follows this form, then we're going to find our integrating factor, which is e raised to this one, p of x integral, okay, and then dx we have here, dx for this part. So for this part, we will write our integrating factor here. We'll make use of our integrating factor equivalent to e, and then raised to the integral of our supposed to be p of x is 10 over L. 10 over L. And then we have here dt. Okay? So, again, this equation follows this form, which is first order linear differential equation. So, we find the value of our integrating factor. Okay, going back to this one, our integrating factor now. Okay, integrating factor, that is the integral of 10 over L dt, that is 10 over LT. Okay, 10 over L times T. Okay, that is now our integrating factor for this part. Okay, so I will erase this part. I will rewrite our integrating factor here. You have here e raised to 10 over L times T. That is our integrating factor. Now, once we find our integrating factor, of course, we will multiply to this equation our integrating factor, so that we will write again di over dt plus 10 over L times I, which is equivalent to 100 over L. And then we will multiply both sides by our integrating factor, that is e raised to 10 over L times t. So when we multiply this one to this part, we have here I e raised to 10 over L times t. Okay, and then on this part, of course, we will multiply our integrating factor. The result is 100 over L, and then we have here e raised to 10 over L times t. Okay, and then we will integrate this part, and then with respect to t. Okay, this is e to the u du. Okay, our formula here is e to the u du. Now, if this is e to the u du, we will write here integral as, sorry. Okay. Now, we will write here on this part the integral of e to the u. You have here e, and then 10 over L t dt. If we have here e to the u, our u for this part equals, our u here equals 10 over L times t. And then the derivative of u, okay, that is 10 over L. 10 over L dt. Notice this is only dt, so using u substitution, we can write here, so I will write here 100 over L. So using u substitution, this one, okay, we will write first the reciprocal of 10 over L, that is L over 10. And then we have here e raised to 10 over LT, and then 10 over L dt. This is u substitution, so that this will become the integral of e to the u du. This is our du. If you have noticed, du 10 over L dt, so that will be our du. And then e to the u, e to the u. We have here our u, so we have our multiplier L over 10. So that we will multiply now L over 10, integral of this one, you have e raised to 10t over L, and then 10 over L dt. Okay? Which is then equivalent to cancel L to 100 divided by 10, that is 10. Okay? So we have here 10 e to the u, which is e raised to 10t all over L. Of course, we have here plus c. So I am rewriting this one as I e raised to 10t over L. If you have noticed, we have here a common e raised to 10t over L, e raised to 10t over L. So we will multiply its reciprocal. So 1 over e raised to 10t over L. So when we multiplied, the remaining value here is I, which is equivalent to, so cancel yung e raised to 10t over L. So we have here 10 plus c all over e raised to 10t over L. Okay, so this is now the result when we multiply. Okay, if we multiply the value we have here, okay, I will write our multiplier. Let's say we will multiply it by 1 over e raised to 10t over L. So cancel. So what remains here is I, and then equals 10 times 10e multiplied by this one, we will cancel e, and then plus c times this one, so the result is c over e raised to 10t over L. Okay, so I will change back to my color of pen. Okay, now next part is, of course, we have now I equals 10e, I mean 10 plus c over e raised to 10t over L. Now going back to our problem, we have if the current is initially 0, in other words, at t equals 0, our I is equivalent to 0 based from this statement. So that when we substitute the value of I and t, so this I becomes 0, which is equivalent to 10 plus, we have here c. Because when we substitute the value of t as 0, so 0 times 10 over L, that is 0. E to the 0 is equal to 1. Okay? I will write here E 10 times 0 over L. 0 times any number or variable, that is e to the 0. I mean 0. So you have your e to the 0, that is equivalent to 1. Okay? So e to the 0 is equivalent to 1. Therefore, c divided by 1, that is c. So for this case, our value of c is equivalent to negative 10. We will transfer c to the other side, that becomes negative. So here, c is positive, and then 10, it becomes negative on the other side. So this time, we have the value of our c. Okay? So once we find the value of c, of course, we will find the other. Okay, so after we find the value of c, then we will find other variables, the value of other variables. Okay, so based from this equation, at t equals 0, so we find the value of c. Now, if the current is initially 0 and is equal to 9 amperes after 1 second, okay, so this time we will be using this this statement, no? If we have our t 1 second and then I equals 9. So this time, if at at t is equal to 1, our I is equivalent to 9. Okay, so this time if we substitute the value of t and I and c, we will find the value of L from this equation. Okay, by substituting the value of I, which is equivalent to 9, which is equal to 10, based from this equation, and then plus the value of c equals negative 10 over, we have here our e raised to 10 times time 1. Okay, so 10 over L. So that is 10 over L. Okay, so let me erase this one first. Okay, so we have 10 over L. 10 over L. Okay, this time we will multiply both sides by 10 over L. So the result now, we will combine this one first. So when we combine this one, okay, so we will just transfer this one on the other side and then 9 on the other side. So that becomes 10 over e raised to 10 over L, which is equivalent to 10 minus 9. We will transfer this one to the other side, that becomes positive, and then 9 to the other side, that becomes negative. So 10 minus 9, that is 1. Okay, and then this one, 10 over e raised to 10 over L, which is equivalent to 1. So that this one multiply, you have here 10 equals e raised to 10 over L. Okay, so this is now the result when we do the transposition from this equation. So that I will write now, when we do the transposition, this one is equivalent to 10 equals e raised to 10 over L. Okay, so I will now erase this part. Allow me to erase this part because of my limited space. So from this equation, we will apply ln to both sides. Okay, so ln of 10, we have here, okay, so sorry for that one, ln of 10, okay, for a while. Okay, we have this one. When we apply ln to both sides, this becomes, for this part, that is ln of 10, that is equivalent to ln, or the natural logarithm of e raised to 10 over L. So this part, ln of e raised to 10L, that is equivalent to 10 over L. So we have here ln of 10 equals 10 over L. So the result of letter L, we will find our L equivalent to, L is equivalent to 10 over ln of 10. So when we use calculator, our L is equivalent to 4.34. Okay, 4.34 henries. Now we have already the value of L. Find L. Okay, so this is our L, and then this time the current after 5 seconds. So we're going to find the current after 5 seconds. So this is now, we will be using back to this equation. No? So I is equal to 10 plus, we will substitute all the value of our time and then L. We have the value of L. So I will write I. We're going to find the value of I from this equation. This one. Okay, I will erase this part. Okay. Okay. So going back to our discussion, I is equal to, we have here 10, and then plus C. Of course, C is negative 10. We will now substitute all the values. We have here negative 10. Or I will write directly this, instead of writing positive, I will make use of the negative sign. So minus, instead of writing positive, because negative times positive is negative. Okay, so we have here our e raised to 10 times time. Our time is 0.5 seconds. So 10, I will write here 10 times 0.5. Okay, 0.5 all over L. Our L is 4.34. So that is e raised to. Okay, I will rewrite this one. I will rewrite this one. So this is now 10. And then we have here e raised to the exponent. Using your calculator, the value of I, okay? So you can find the value of I. You can make use of your calculator to find the value of I. So in my case, I don't have the value of I. Anyway, use your calculator to solve the value of I. E raised to this one, okay? So we have the value of I, and then we have the value of our L. So this is how we compute this problem: electric circuit application of differential equation.